Hi, this is Peter Todd from the Industrial Maintenance Roundtable in New South Wales. What I'm doing today is doing a quick demo on a very simple ultrasonic vibration meter. Ultrasonic vibration meters convert very high frequency sound into both an audible through a earphone output or a visual display. So ultrasonic vibration meters are very useful for things like detecting leakage through the high frequency sound that's generated by leakage turbulence, fluid turbulence. It's very useful for detecting things like friction and lubrication issues, and it's also used in the electrical area for things like tracking, corona and arcing. So in this application, what I'm going to be doing is just doing a simple demo test on internal leakage of some valves. This is something that you can trial yourself just to get used to using a ultrasonic vibration meter. So the controls on this meter are very simple. So it's an on-off button and a sensitivity control. So currently I've got it on its high sensitivity. So if I press the on-off button, then rub it on the end of the probe on the sink, then just a little bit of friction between the end of the probe and the sink produces quite an output. You can see the row of LED lights lighting up. The higher the level, the more the sound. So what I'll do is I'll simulate so I can test these two valves at the moment. So if I have a bit of friction, so what I've got to do is to put the probe on the valve, make sure there's no movement, and currently there's no noise output from that valve. And after any contact friction dies down, there's no output from that valve. Now while I'm contacting this valve, if I turn the tap on, then I've got quite a high level of output from that, just a little bit of leakage. Now if I do the same test on the other valve, because it isn't leaking, then the sensitivities, the output on the LED lights is a lot lower. So that's how most internal leakage diagnostics work. It's a comparison between two similar objects and as a comparative analysis. So if I turn up the leakage on this other valve, even though I'm not measuring on the valve that's leaking, I'm still measuring some level of noise because of the noise that's transferred through the pipework. So it's about a 30 to 50% sensitivity. If I go back over onto this one that's actually leaking, it's well over 100% sensitivity. So we can do the test the other way. I can put the meter over on this valve, start the leakage going, and I've got a reasonable level. And so if I didn't know which valve was actually leaking, then I can use this as a simple test. Say yes, there's a reasonable amount of output from there, and on this other valve there's no output. So the conclusion is that that valve is leaking there. So there's a few things that could disturb it. If there was another valve with producing a lot of noise not too far away, it could drown out the small amount of leakage noise from this small amount of leakage. Thank you.